Now you talk about Clapton being an early influence of yours, but I think you also were listening to Jimi Hendrix.
Not so much, actually.
No?
No.
Jimmy Page?
You know,
those guys?
It's like no, not really. Unless there were songs that Alex or bass player at the time, Mark Stone, would come in with an album and say, "Hey, you want to learn this song by this band?" I wouldn't. I usually wasn't the one to pick the songs we played.
It's interesting because all of those iconic guitarists, they all played off the rack guitars. You're the only one who said that's not good enough for me.
Well, obviously it was good enough for them, but it wasn't for me. You know, doesn't mean anything except that, really.
Well, the sounds that you were making and with Van Halen really kind of changing the musical landscape, it really kind of inspired a whole era of copycats.
Yeah, which at first, I kind of went, at first it kind of pissed me off. Then I started thinking, oh God, what did I start? But then, my brother and my father both told me, hey, imitation is the biggest form of flattery. So I just let it go at that. Yeah.
Welcome to Practical AI, everybody. My name's Jeff, and I'm with Peter Lynn. Peter, today, I want to just pick your brain a little bit on transfer learning versus starting from scratch. Give us a little bit of wisdom and understanding of how this typically works for the ML engineer, the benefits of transfer learning, and whether starting from scratch is a good next step or a good place to start.
Great question. I would say most platforms today recommend you use transfer learning. For example, RoboFlow it's a popular website that lets you create data sets, annotate them. So you take your photos, you upload it to the website, and you can tag by drawing boxes around stuff. So if you're doing, let's say you're a farmer and you want to categorize different kinds of tomatoes. You take thousands of pictures, you upload it, and then you draw boxes around tomatoes and go, this is a Roma tomato, this is a beefsteak, this is a Cherokee purple. And you do all that. And then they have some pre-built models, which we call it foundational models or backbone models. But they mean the same thing. The idea is that they've taken ImageNet and trained a model on ImageNet so that it's figured out some basic things about what things are important in pictures. So like lines and shapes and colors and stuff like that. And so it's learned all these like generic features that in theory, you can transfer that to a new use case. So that's why it's called transfer learning, because you're taking a model that someone has trained, and then you're just customizing or fine-tuning it to this new use case that you have.
I see. Okay, so transfer learning is essentially, it's a generic starter kit that should get you pretty far in your specific use case. It's not a generic, but it's a smart model that should be able to get you from not point A to point C, but from point C to Z, essentially.
So that's the idea. That's the sales pitch. In practice, not really.
Okay. What's the down? What happens with transfer learning? What normally is the breakdown?
So typically, if we look at category competitions, all of the category competitions start with a base model like ResNet, DenseNet, MobileNet, kind of the stock ones that Google provides. And then you take the competition data set and you train it. When you look at the actual results, most of the teams outside of the top 10 only get to about 50 or 60% accuracy. Which
with the base model. And why is that?
Well, it's because it depends on how different your data is to ImageNet. Right? Like as big as ImageNet is, it's got a finite set of things that it was trained on. And therefore, if your data set has drastically different things it's looking for, let's say you're creating a mining data set and you're taking pictures of minerals in a mine with poor lighting. Well, that's very different than what ImageNet is.
Sure.
And so chances are it didn't learn the kind of features that would be present in pictures of mines underground versus pictures of normal things in well-lit places. And so if you take ResNet and you try to train it for your mining thing, it's probably not going to work because it's just missing. It hasn't learned the features it needs to look for. And so when you start to train it, you have two options. You can say, yes, modify the base weights in that foundational model, or no, keep the weights frozen. Well, if you turn it on to yes, update the weights, you're actually fighting against it because it's already learned what it thinks is important. What are the important features? But they're really different than what your data set has. And so now it has to unlearn, it has to move all those weights completely in a different direction to figure out like, oh, a bunch of sparkly things means that it's copper or silver.
So is it safe to say that in some instances, the transfer learning becomes an impediment? You're
It
actually,
is.
you're working from something that is so, it's just not helping you.
No.
And
In fact, back in, was it 2018, 2017, there was a competition for one of the oil gas companies had sonar images that they had collected, and they wanted to be able to train a model to figure out where it should drill for oil and natural gas. And everyone started with the foundational models, ResNet and DenseNet and MobileNet, and everyone got terrible results, which meant that you really should have started from scratch.
okay, so pivot into that. So starting from scratch, the upside, I suppose, is that you could outperform transfer learning, the training through transfer learning. But what are the downsides of starting from scratch?
The main downside is it probably won't work broadly for a wide variety of things. So if your goal is to create a model that does a whole bunch of stuff, you're probably better off to start out with ImageNet because it's been trained on a wide variety of things. If you want a model that's very specific to your particular use case, it's probably better to start from scratch because you're not trying to boil the ocean. You're just trying to do one little thing. You just want one cup of coffee.
Yeah.
Make a cup of coffee.
Yeah.
Instead of boiling the ocean.
Okay, so when you start from scratch, are you actually starting from scratch and writing like layered code for each layer and all that, or are you using some base algorithms or base models or something and working from something?
Yeah, so most people will look at the popular models and look at the sequence of layers and kind of borrow from what they've done. So a common thing is like you have a convolutional layer with some max pooling and then maybe some other layers following that. And so they do these in blocks, like they'll do 4 of those. Convolutional 2D plus a max pooling or batch norm, and then do 4 of those as one block, and they'll do like 8 blocks of those. So you just take one block and then start from scratch. So when you start it, it randomly assigns the weights at the beginning, and then it learns. Whereas a transfer model has already learned the weights, and so when you load it, it's the weights that it's learned because Google's done the training for months or days or whatever it takes. And then you're starting from that as a starting point.
Okay, so there's lots of questions then on versions, like versions of the transfer models, but also versions of people's, start from scratch models. Is the open source community building an arsenal of these little starter? Like I started mine from scratch, and here's one that I used to pick, copper versus zinc.
Yeah, so there's a lot of models up on Hugging Face.
Okay.
Most of them are actually variations of the canned ones that Google provides and Amazon and Microsoft and so on. So everyone is kind of building on the bigger ones because everyone's trying to do these big models that just does a lot of different things. But most of the times it's probably not the best place to start because like one thing is those models tend to be bigger.
Yeah.
If you can get by with a model with only 1 million parameters versus 50 million, well, that reduces your training time by 50 times.
Processing power, costs, everything, right?
And if you want to do rapid iterations and turnaround, waiting 30 minutes is fine. Waiting 8 hours or 2 days or 3 days is, it's a real hassle, because like, well, if I started on Thursday, it won't be done until Saturday, but do you want to work on Saturday? So now okay, no. So now maybe I started on Friday night, so it finishes in time. So the Monday morning I come in, I can look at the results.
Okay, so what I'm hearing ultimately is that transfer learning is a great place to start to get a feel for, how models work and, what the training could be like. But transfer learning is probably more associated with boiling the ocean, collecting or seeing all images or identifying anything. Whereas what you're saying is maybe once you kind of get comfortable in machine learning, get away from the monolith models that do everything and start from scratch, building a model that does something really well and see if you can do that. Is that fair?
Yeah, it's just being practical. You can get more done more quickly with smaller models from scratch than you can with a bigger model using transfer learning.
Great. Well, thanks for the advice, Peter. This is helpful. Transfer learning versus starting from scratch. Be sure to ask questions and we'll try to answer them for you. Take care, everybody.